Alright everybody, you can thank Sarah for that video. That was pretty cool. I thought optical illusions were pretty neat to see. It's all about your perspective, but alright. Proving triangles are similar. Okay, so we just talked about similar triangles and what you need for them. Now we're jumping off and we're taking a look at how to prove them. Alright, so we have a few things that will help us along the way. We do have the AA similarity postulate from yesterday, but now we're going to introduce two more. And they should look eerily familiar because we've dealt with these before. Theorem 8.2, side-side-side similarity theorem. If the lengths of the corresponding sides of two triangles are proportional, then the triangles are similar. So basically what we're doing here is, if I say AB, this over this is equal to AB over PQ equals BC over QR is equal to AC over PR. Then you're allowed to say that triangle ABC is similar to PQR. Okay? So it's the same idea. We had this before with congruence. Okay? Congruent triangles, if all the sides match up, they're congruent triangles. But here, instead of saying all the sides are congruent, we're saying if you set a ratio of a statement of proportionality for each triangle, so AB over PQ, BC over PQR, AC over PR, and they all have the same ratio, then they're similar. Okay? The same works for SAS. So if I have angle X congruent to angle M, and the corresponding sides around it are proportional. Okay, so over here, if an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides including these angles are proportional, then the triangles are similar. It has to be the sides around it. Okay, so you could say like, and XZ over MP is equal to XY over MN. Then you can say triangle XYZ is similar to triangle MNP. Okay, so same idea. The only thing different is they're not congruent like we did before, but now they're proportional, same ratio. So for number one, it says using the SSS similarity theorem, which of the following three triangles are similar? Okay, so I'm going to go ahead and pick like, let's go with these first two. Okay, I'm going to do small triangle first over this medium triangle. I'm going to do the small side over the small side. So in this case, it's 4 over 6, small over small, medium over medium, 8 over 12, and then do large over large, 10 over 15. Just take a second to reflect on that. I took the smallest side here and put it over the smallest side here. That's how I got 4 over 6. I took the medium side over medium side. Okay, if I reduce these down, guys, you may cloud use calculator for this. Okay, it's when you do 4 over 6. Okay. Oop, we'll be getting to that soon enough. So 4 out of 6. I hit math, enter, enter. 2/3. Okay. And if I go through this, I'll actually see that 2/3 equals 2/3 equals 2/3. Okay. So nice. I can say then that these two triangles are similar. Triangle let's go SRQ is similar to WVT. Okay? So we're looking good. Let's just really quickly check out these other ones. So let's check out these two triangles. Okay, small over small. So I can say 6 over 6. See if that equals to 12 over 10, medium over medium, is equal to large over large, 15 over 12. 1 equals 6/5 equals 5/4. This does not work, so these two are not similar. Okay, the only other ones I could have are these three out here. Or sorry, these two. So small over small, just up here, 4 over 6. Medium over medium, 8 over 10. And then large over large, 10 over 12. 2/3, 4/5, 5/6. Okay, and that is a 5 there. So they are not similar either. Alright, very much the same. It's a lot of the same, but at the same token, it's you gotta get this practice, get good at it. So down here it says which of these following three are similar. Let's take a look here. Let's go with the first two again. Why not? So I'm doing small over small. I can do 12 over 15. Medium over medium, 16 over 20. And I can do large over large, 20 over 25. Reduce by 3, you get 4/5. Reduce by 4, 4/5. Reduce by 5, 4/5. And it works out again. Getting lucky with the first two here. So I can say triangle KML is similar to triangle NQP. And I am actually doing this in a certain way too, like KML, I go small, medium, large. And here I go small, medium, large. You have to make sure your letters match up. That's important, okay? Just to save a little bit of time, I'm going to go to the back, but you can try out the other two on your own as well. Try out these two, try out those two, okay? All right. Use the given lengths to prove that triangle DFR is similar to MNR. Okay, so I already have angle D is congruent to angle M, which is good. So I got to have the ratios around it be the same. All right, looking up top, the whole thing's 10, this is 2. So MR then is going to be 8. So let's make up a ratio. I can say 8 over the whole thing, 8 over 12. Oh, sorry, 8 over 10. So small over small equals 12 over 15. One of the hardest things for you guys to realize is that I have a triangle inside of a triangle. Okay, 8 over 10 can be reduced down to 4/5. 12 over 15 can be reduced down to 4/5. Guys, you've showed me everything you need to prove it, so it worked. Yay! Okay, you got what you needed. Number 4, use the given lengths to prove that these two triangles RSV is similar to triangle YXV. In the middle, these are congruent by vertical angles. Okay, so I can say angle RVS is congruent to angle YVX. And you doing this is good enough too. Let's compare sides. 15 over 18. See if that's similar to 20 over 24. Reduced by 3, 5, 6. Reduced by 4, 5, 6. Yes, the smiley face is important. Make sure you include that. Okay. Number 5, draw the given triangles roughly to scale, then name a postulate or theorem that can be used to prove that triangles are similar. Okay, so you're going to be drawing a little picture here, right? I have a triangle ABC, so let's draw a big triangle ABC. ABC. And I have triangle XYZ. XYZ. They're telling me angle A is 38 degrees. Let's label it appropriately. Angle B is 94 degrees. Yes, I know it's not drawn to scale. It's okay. Okay, just draw a regular triangle. And triangle XYZ, boom, 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 Y is 94 degrees. And Z is 48 degrees. So, can I say they're similar or not? Well, okay. Over here, I'm going to add 38 and 94 together. That gives me 132. You can always remember that the triangles, three angles have to add to 180. So if I know it's 132, subtract that from 180. That gives me 48 degrees. Well, wouldn't you know it, over here, I already have 94 and 48. That means that this has to be 38 degrees. Okay? So you can say that triangle ABC is similar to triangle XYZ. And this is actually from the last notes we took a look at. Angle, similarity, postulate. Okay. We'll give you those three. It's AA, SSS, SAS. Those are your three similarity theorems / postulates. Okay. All right, down here, take a look at the second one here in triangle ABC. So again, I'm labeling it. Triangle XYZ. So B is 50 degrees. AB is 4. BC is 9. Okay. Y is 50 degrees. XY is 2. YZ is 4.5. Alright, I've got my angle. B is congruent to Y. Let's check out the sides around it. Now I'm going to do small over small, so 4 over 2. See if that equals 9 over 4.5. 4 over 2 reduces to 2. 9 divided by 4.5 is 2. They're similar. So guys, look, I have a side, I have an angle, I have a side. Right? So this is my SAS similarity theorem. Okay? So that about wraps us up. What did we learn today? Okay, well, we learned about SSS, SAS to prove triangles are similar. Okay, we just set up a bunch of ratios. Okay? And again, the one thing I really want to stress out to you guys is here, what you actually have is you have a big triangle, R, D, F, and you have a small triangle, R, M, N. Small, big. Okay? So if you need to draw two pictures out to help you, go for it. That'll help you big time. Alrighty? Okay, guys. Keep up the good work, and as always, good luck. We're all counting on you.